Next, we're going to find curl of f for example A. Okay, for curl of f is equal to del cross f. Del cross f is really the determinant of a 3 times 3 matrix, where the elements in the first row would be the standard unit vector I, j, and k. Second row would be the components of vector del, which is partial x, partial y, and partial z. And in the third row would be the components of vector field f, which are x, y, z, y, and x. Okay, so now we need to find the determinant of this. And remember the sign alternate from plus, minus, plus. Okay, so for the x component, I'm going to use a pointy bracket here so that we use less space. For the component of x, what you do is you cross out first row, first column, so you end up with a 2 times 2 matrix there. Okay, so the determinant of that 2 times 2 matrix would be partial y of x minus partial z of y. So that would be the x component. And for the y component, the sign now alternate, and you cross out first row, second column. For y component, you cross out first row, second column, and remember the sign alternates to negative. Okay, cross out first row, second column, you end up with partial x minus partial z of x, y, z. So that is the y component. And then the sign is positive again. Cross out for the z component, you cross out first row, second column, first row, third column. Then you end up with a 2 times 2 matrix. So the determinant of that would be partial y partial x minus partial x, y, z partial y. So that would be the z component. Go. Alright, now let's simplify this. The first component, differentiate x with respect to y will give you 0. Differentiate y with respect to z will give you 0. So the x component is 0. The y component, we have partial x, that's a 1, minus differentiate x, y, z with respect to z will give you xy. And the z component, partial y, partial x, that would be 0, minus differentiate x, y, z with respect to y, that will give you xz. Okay, now simplify this. We have 0, xy minus 1, negative xz. Okay, so that is curl of f at any points x, y, z. Okay, now we want to find the curl of f at a particular point, which is at point 1, 2, 3. So now what we're going to do is just replace x with 1, y with 2, and z with 3. So the x component is still 0. The y component, we have x times y, which is 2 minus 1, so that's a 1. And then we have negative, x is 1, z is 3, so we have negative 3. So this is curl of f at point 1, 2, 3. Okay, now let's look at the second example, item B. In item B, our vector field is on the xy plane because we only have x and y components. Same thing, we need to find the divergence of f and curl of f, but this time we're not giving you any point, so it's going to be in general for any point xy. Okay, so let's find divergence and curl of f for example B. So in example B, this is our vector field. Okay, first we want to find the divergence of f. So remember, divergence of f is going to be a scalar. Okay, so this is equal to del dot f. And for del, the components are partial x, partial y. And for f, the components are 1 for the x component, and for the y component we have x squared plus y squared. Okay, now dot these two vectors. So first term would be partial 1 partial x. So we differentiate 1 with respect to x. It's ugly. Okay, hang on, let me rewrite that. So x times x, that will give you partial 1 partial x, and then we have plus. Now component y with component y, we have partial of x squared plus y squared with respect to y. Okay, now the first term is 0. Second term, differentiate x squared plus y squared with respect to y will give you 2y. So this is equal to 2y. So the divergence of f is equal to 2y, meaning that when y is 0, there is no divergence. When y is positive, then the divergence is positive, meaning that we have a source point. But when y is negative, then we have negative divergence, meaning that we have a sink point. All the vectors in the vector field are moving towards each other. But when y is 0, the divergence is 0 for this particular vector field f. Okay, next is we want to find curl of f. Okay, curl of f, missing L there. Curl of f. Okay, curl of f is equal to del cross f. Okay, so it's going to be a determinant of a matrix. Alright, so here our vector field f has only x and y component, but here we still have 3 times 3 matrix. We have I, j, and k. Del would be partial x, partial y, partial z, and the third row would be components of f, which are 1 for the x component, x squared plus y squared for the y component, and 0 for the z component. And the technique of finding the determinant is still the same as before. So the sign alternates: positive, negative, positive. Okay, now let's get the x component. So the x component, what you do is you cross out first row, first column, so you end up with a 2 times 2 matrix here, this one. Okay, so the determinant of that would be partial 0 partial y minus partial x squared plus y squared partial z. So that is the x component. Now for the y component, you cross out first row, second column, that's for y. Oops. Okay, first row, I cross out wrong row. Okay, so we have, we cross out first row, second column, and remember the sign alternates to negative now. Okay, now when you cross out first row, second column, you end up with 2 times 2 matrix, where you have partial 0 partial x minus partial 1 partial z. Okay, and the z component is positive again. Now we cross out first row, third column. So cross out first row, third column, you end up with a 2 times 2 matrix, where you have partial x of x squared plus y squared. So we have x squared plus y squared. Differentiate that with respect to x minus partial 1 partial y. And some of you can do this very quickly. Okay, so first term will give you a 0. The x component will give you a 0. The y component will give you a 0 as well. And the z component will give you 2x minus 0. So this is the curl of f. As you can see, f here is a 2 times, f is a vector field in 2D. So if it's in 2D, it's going to be on a xy plane. So if it's on the xy plane, if there is any orientation or circulation, it would be on the xy plane. So probably, let's say your vector field is like this. If there is circulation, so the circulation would be on the xy plane. So remember, del cross f will give you a normal vector to the circulation plane. So if there is any circulation plane, the normal vector to the circulation plane, which is on the xy plane, would be pointing upwards here, where x and y components are 0, but the z component is non-zero or 0, depending on if there is any circulation or not. So you can see here the curl of f give you 0i, 0j, and then we have 2xk. So in this case, the normal vector is pointing either upwards or downwards, depending on the value of x. So if x is 0, then there is no circulation. If x is positive, the normal vector is pointing upwards. If x is negative, then the normal vector is pointing downwards. So del cross f will determine whether there is circulation in the vector field. If it's a 0 vector, then there is no circulation. If there is curl is non-zero vector, then there is circulation in the vector field. Okay, how are we doing with time? Okay, all right, that's it. Thank you.